Hi there, welcome back to our channel. And now we are exploring the power of KiCad, a free schematic drawing and simulation software. It also allows you to do your PCBs based on your circuits. And now we are trying to understand how this software works here. So what I have done is I have taken a couple of resistors from the library. They are all same values, 1K each, and then I picked up one voltage source, a DC voltage source, and then there is this ground. And I have connected them in this fashion, 1K each connected in parallel with and across it there is a 1 volt source. So how I did that, here you can see there is a add symbol uh, icon. I clicked here and it opens up the symbol library. So for example, I wanted this voltage source that you see on this schematic. So I just typed here source in this. You can type it here, for example, source, and it gives me range of different sources, that is behavioral voltage or current source. Then there are voltage dependent, current dependent sources, DC current source, exponential current source. But I want a voltage source. So what I'll do, I'll scroll down and see where is that. So here it is. So I have this amplitude modulation voltage source there, which can give me amplitude modulated signal. I want a DC voltage source, very simple exercise for this now. And then there are so many other things like sinusoidal source, etc. So let's select the voltage DC source, which is DC. And after selecting that, I clicked OK here. There is no footprint specified for this one. And here is the information, voltage source, DC, keyword simulation. There is a reference. You can scroll down and there are symbol pins, that is one is positive, two is negative. So as you can see in the picture right here, we can see this picture. There is the pin 1, pin 2, and that's it. So you can click here, select with a browser also, then it opens up your symbol library browser, and in that situation you have to go to simulation spice section, and in that simulation spice you can search for VDC. Okay, here you can also write VDC, and then that comes here, right here. And what you see here, like I said, this is how the pin looks like. These are two pins. Now we have done that. We just close it, and we have placed this on the schematic. Okay, so I right click here, I click here again, and this is the voltage source. Let me find out where it is. Here it is, VDC, and after that I will click OK. Okay, and here is how I placed it. I press escape from my keypad to get rid of it. Now, what about if I right click here? I see, I see by right clicking, it doesn't give me the option. But before that, I have to, you see, there is small amplifier symbol in the mouse that I'm hovering. So to get rid of it and select the voltage source, I press escape button, and now it is gone. And now I right click on this component where I see there are options, and the main option is you have these properties. Click there, and the fields are there. The value I have chosen it to be 1 volt. I can choose, for example, 5 volt also. So let's keep it 1 volt. Then simulation pins are given, data sheet, footprint there, and that's it. Here if I click simulation model, of course there is no simulation model for this one, but I can see that in the simulation model editor you can see that it's a built-in spice model for the voltage source. It is a DC type. There are a range of voltage sources available. Then you have DC values set. I click OK, and let's do that. Now, what about the resistors? Can we find the resistors here? Again, go to click here, the library, and simply type R. And here is your resistor. Double click it and you get this resistor here. But now there is a different resistor I have chosen, but you can choose that also. What about this ground? So for a ground, I click here, power symbol, and now I want to show you that for the power, I will click here, or maybe just cancel it. There are many items here. I'm going to explain you about this power flag concept soon. So when I do that, I have this ground. So it's a power symbol that creates a global level with the ground here. So I will choose that. As you can see that I will click OK, and I will place it on the schematic, what I have done. So now that is done. Next, I will just delete it. I don't want this. So I will delete it, and that's it. So now, before I take you ahead, I want to show you that I have added this power flag. It tells the software basically where the power is coming from. If I don't add it and run the error rule check or electrical rule check, ERC, then I might end up with the error. So let's do that. Let me show you if I don't add it. For example, I delete it first, delete it, and I will say that one. And let me save it first. And now I want to run the DRC for this. So where is the DRC? DRC is the error rule check, actually electrical rules check, ERC. So I click here, perform error rule check, and then I click run ERC. Now here I'm getting the error which says, look at this arrow is highlighting here. It says this error is input power pin not driven by any output power pin. So it means the software doesn't know whether there is a power in the circuit where it is coming from. So this is the symbol PWR, or hidden pin, ground, power line, etc. So to get rid of this error, what we'll do, we will click the add power symbol, and now we will search for power flag actually. So just type here PWR, and then here it comes. So it's a special symbol for telling the ERC where the power comes from. Okay, and I double click here, and here I place that symbol. I press escape from my keyboard. Then I need to make the connection. So I click wire here, and I will just add this right here, and now it is done. So I save it again, and then run the electrical rule check again. So I click, and now I run ERC again, and boom, very good. I have zero errors, zero warnings, and circuit has passed the ERC test very well. Okay, so here is the zoom out, zoom to fit home. I can zoom to objects also, so it comes on the screen very well. So now I have done that. So what is, let's say, DC volt of 1 volt. So the voltage across the both resistors is going to be 1 volt. And the currents through the resistor, of course, the total current will be 1 volt divided by 2K. That is 0.5 amps. Okay. 0.5 milliamps actually. And the current will be divided into equally between the two resistors, and the voltage across all the resistors remain same, that is 1 volt. So we want to do this operating point analysis. So we'll do simulate circuit in the spice. So we'll click here. Before that, I would like to add some nets. There is this ground here because I need to know on what net what is the voltage. So if I right click on the net, I have option of adding label. Okay, so let me call it node A. For example, here is my line A. Okay, that line A comes right there. So if I highlight it, for example, do I have a option of highlighting it? How to do that? So look at this option, highlight wires and pins of a net. So I select this and I click here, and that's the whole net A there. So on the net A, I have this voltage. And here, of course, it is the ground. So obviously is there. So let's run this simulate circuit in Spice. I have done that. Then I will choose simulation command. I click here. Now I have so many analysis. Remember, we have done this in other Spice program also. So want to do operating point analysis, and this tab has no settings. I would not select this. I can choose the configuration, whether it is Spice, PSpice, LTspice, and so many other Spice programs are there. So I don't give it any. I click OK. And after doing that, I will click run or stop, run simulation. Run simulation will give you me the currents and voltages into the circuit. So you can see now I have simulated the circuit successfully without any error, and it gives me these results. So let me see those results. So here I see note no compatibility mode selected, circuit KiCad schematic. I am doing the analysis as room temperature, that is 27 degrees Celsius. Nominal temperature is 27 degrees Celsius. And the current through the resistor R1 is 1 milliamp. Obviously, the current through the R2 is 1 milliamp, and the current delivered by the source is -2 milliamp. The voltage at node A is 1 volt. So the currents, the total current is the current total current is 2 milliampere basically. Because R1 and R2 in parallel, their effective resistance is 0.5 K. So 1 divided by 0.5 K, that is Ohm's law, gives you 2 milliampere current, and then 1 milliampere in each resistance that current is divided. And the total current is 2 milliamp, and total voltage across the nodes is 1 volt. And that's how you finish successfully the very first circuit in KiCad. You learned how to pick up the components from the library, how to pick up the voltage source from the library, how to add power flag, how to add ground, how to make connections, how to level the nets, and then how to set up the analysis and how to run the simulations and verify your theory and results with the simulations. How about you click again simulation command and use a specific configuration. Let's say you want to go for LTspice. Click OK and run again. And here are your results. They are same. Of course, they are going to be same. Again, click, select, for example, PSpice. Click OK. And it says that reset reload circuit. Again, run the simulation, and the results are same. Again, click simulation command, go for simple spice, click OK, run simulations, and the results are gonna be same. How about you have HSpice? Click OK and run simulations. Okay, here is an option like if you want to plot some signal, here is the probing. You can probe a specific node or specific node voltage or current through any component. Now there is a tune component values. This is a very interesting one. For example, I choose R2. So I click here. Once I click there, I can see that I have this option appearing here. So RK values ranging from 500 ohm to 2K. Okay, now I select here, for example, let's say I choose the value of, I vary the value of RK to, let's say, 500. So if R2 is 500, now the current through it gets double, and the current through R1 remains 1 milliampere as before, and the total current is 3 milliampere, obviously. So here you can actually tune the values. Let's say it is 2K, then the current is half through the R2, and current through R1 remains same, and the total current in the circuit has changed to 1.5 milliampere, and this is how you can do it. Similarly, you try this for doing for R1. You can also click the voltage source, for example. After clicking the voltage source, you now have, okay, you first delete it. Let's say you click tune and select the voltage source, and then see if it comes out there. R1 is coming there. We'll see that. Yes, R1 is coming there. What about the R2? Do you want that? Okay, we'll see that. Check it out. Okay, so it seems like the voltage source is not getting tuned there. So we'll see that add signals. You need to run plot providing simulation results, because we haven't done any we don't have any graphical results, because we haven't swept any parameters except this tuning of the resistor values. But I hope you understood how to run the basic simulations, and how to, you can click the simulation and show spice netlist. Click here. Now you see that's the ready-made spice netlist. You can save it in the notepad and open it with other simulators such as LTspice, HSpice, PSpice. Just open this file. And we have done a lot of tutorials earlier using how to generate the spice netlist, how to run it, and all this. So it says there is a title first, then that's the save all command, that's the probe le operating point analysis.op. R1 is saying connected between node A and ground with a value of 1K. R2 is connected between node A and ground with a value of 1K. Voltage source is connected between node A and ground. It is a DC voltage source with a value 1 volt, and dot end ends your spice. That's it. So hope you understood the basic of how to run KiCad, how to draw the schematic, and how to run your first analysis. If you like this video, click like button, and main point was this PWR FLAG. You need to add this, because otherwise your ERC will not pass and you will end up with the error. So wish you happy learning. Stay tuned, share it with others, like and subscribe to the channel, put some comments if you have some opinions. Wish you happy learning. Stay tuned.